Okay, so good day everyone. So in our previous lesson, we learned how to use U-substitution to simplify integrals involving basic functions. But as we move forward in our subject calculus, the problems we encounter became more complex. Those powers, exponentials, square roots, and even definite integrals, if we still have time for that one. And that is why in this lesson, we'll take our understanding of U-substitution to a higher level. So we'll explore how to identify the right substitution, handling challenging integrals, and apply this method to more advanced functions. So remember, U-substitution is like finding the hidden key that unlocks a complicated integral. So once you recognize the pattern, or maybe the inner function or its derivative, even the toughest looking integrals became manageable. As long as you know the concept behind this topic, integration using U substitution, whatever problem that you may face, as long as you know the concept, then that's even good thing in finding a solution to a particular function. So let's get ready to think critically, simplify smartly, and see integration from a deeper perspective. And let's dive into the advanced applications of U substitution. So let me share my screen first. Advanced integration using U substitution. So I have here, I think, 5 examples for this topic. First example is we have negative 16x cubed multiplied by the quantity of negative 4x raised to 4 minus 1 to the power of negative 5. So then again, let's find first our u. So our u must be the one that we can integrate with a constant. Example, so we can consider this one under the parentheses as our u. So u is equals to negative 4x raised to 4 minus 1. And du, and the derivative of our u. So that will be negative 16 x raised to 3 dx. And find dx. So dx will be equivalent to du over negative 16 x cubed. Pwede put that the negative will be on the top as long as there will be one negative for this function. Let's go back to our function. So we have the integral of negative 16 x cubed multiplied by u raised to negative 5 dx. So we have the value of our dx already, which is du over negative 16x raised to 3. So we substitute, this is negative 16 x cubed, u negative 5, dx is du over negative 16 x cubed. So cancel, let's simplify first. So the remaining variable is u negative 5 du. So our variable of integration is u. Using power rule, let's have another color for this one. Plus 1. Also have negative 5 plus 1. So our answer will be u negative 4 over negative 4 plus c. And since we have the value of our u, which is negative 4x raised to 4 minus 1, so that will be negative 4x raised to 4 minus 1 raised to negative 4 all over negative 4 plus c. So this is the integral of negative 16x cubed multiplied by quantity x negative 4x raised to 4 minus 1 to the power of negative 5. Let's have another example. So we have this example integral of negative 8x cubed all over the quantity of negative 2x4 plus 5 raised to the power of 5. So again, our u should be the one which is or which have a derivative. We can have a derivative and it's a complex or the complex part of the function. So our u is equals to negative 2x raised to 4 plus 5. So next du. du is that is negative 8x raised to 3 plus 5. No plus 5 since the derivative of the constant is 0. So this is negative 8x cubed dx. To find dx, divide both sides by negative 8x cubed. So that is equals to du over negative 8x cubed. Let's go back to our function. Derivative of negative 8x cubed all over u to the power of 5 dx. So the value of our dx is du over negative 8x cubed. That's negative integral of 8x cubed over u5 du over negative 8x cubed. So we cancel out these terms. Remaining numbers are integral of du over u5. So how to answer this one? So we can move u5 to the top. We can have the integral of u raised to 5 raised to negative 5 du. Our rule plus 1. So 5 negative 5 plus 1. So that will be u negative 4 over negative 4 plus c. Then the value of our u is negative 2x 4 plus 5 power of negative 4 over negative 4 plus c. And that is the integral of the function. So you notice that since that's 1 over u5, I think this there is a you notice 1 over u5, we convert that one to u negative 5. Is one of the topics for the laws of exponents. The next question, we have this one, a fractional exponent. Do not worry about this one since this is just the same concept. So this is our u. So u is equals to 5 x raised to 4 plus 5. So du is equals to 20 x cubed dx. Find dx. dx is equals to du over 20 x cubed. So go back to our function. That's u raised to 2/3 times 20 x cubed dx. And the value of our dx. So you have u raised to 2/3 times 20 x cubed. Our dx is du over 20 x cubed. So cancel 20x cubed. So the remaining function is u over u to the power of 2/3 du. So power rule plus 1. And we also have 2/3 plus 1. So 2/3 plus 1, that is equivalent to u 5 over 5, or it's 5 over 3. Since 1 is 3 over 3, because there's 5. We also have 5 over 3 plus c. So we simplify first. This is just fractions, simple fractions. u5/3 multiplied by its reciprocal, which is 3/5 plus c. So simplify, this is 3u5/3 over 5 plus c. So we have the value of our u. Value of our u is 3, 5x raised to 4 plus 5 raised to 5/3 all over 5 plus c. That is how you get the integral of this function with a fractional exponent. Next, this is the last one, and not this is not the last one, it's the fourth one. So we have a exponential or logarithmic equations. So same, we're going to use u as 5 plus L and x, or the natural log. So du, it's very hard to type in the solutions using my mouse. So derivative of ln x, that's 1 over x dx. Then find dx. Dx is equivalent to x du. Going back to our function, so we have u raised to 5 over x, and we have dx. Value of our dx is x du. We have u raised to 5 over x du. Cancel. Remaining value is u raised to 5 du. So power rule is plus 1. We also have 5 plus 1. So we have u6 over 6 plus c. After that one, find the value of u. So the value of our u is 5 plus L and x, or the natural log, raised to 6 over 6 plus c. That is how you get to find your integral. Okay, let's have the last number for this question. So 4x times 4x times sec raised to 4x. Okay, so what will be our u